So here we're looking at a twofold rotoinversion. This example here is from a diagram from the textbook by Bloss. And for the twofold rotational axis, it's shown here. The symbol, we'll just rewrite it here. It's a bar 2. So twofold rotation, a bar 2. That is to distinguish it from a simple twofold rotational axis, which would be symbolized just simply by the letter 2. So you might recall that a twofold axis is the case where we rotate an object 180 degrees. And in that case, we're simply done. We have the new motif wherever that 180-degree position lands. When we have a twofold rotoinversion, we're not done. We're going to add an element of inversion. So there, in this diagram here, there's an inversion point. We'll label it I. In this diagram by Bloss, A1 is our starting motif. Our motif is a hand. It rotates around here 180 degrees. He doesn't show a hand here, and that's appropriate because we're not creating a new motif in that location. We're going to invert it through that inversion point and end up with another hand, A2, down here. Now, you'll notice that if we do the same operation on this hand here, if we rotate it 180 degrees, we end up with another hand here. Although in that case, it's still not a bar 2. We'd have to invert it through this point to complete the bar 2 operation. And when we do that, we'd end up with the same one we started with. So in a bar 2, we just get the same two motifs over and over and over again. It doesn't generate anything besides these two. Now, we want to notice two things about these resulting motifs. The first is that we start with a right hand, and then we get a left hand. And so if you want to impress your friends, you can call that an enantiomorphic pair, as we talked about when we referred to mirror plane symmetry. So we're changing the handedness. That's what makes it a so-called enantiomorphic pair. The other thing that's kind of curious is that you might notice that the bar 2 is the same as something else that we've seen. The diagram actually gives it away, but you might want to pause the video at this point just to see if you might be able to recognize that other operation. Now, what is that other operation? It's indicated here by a mirror plane. That dark circle there, that dark shaded area represents a mirror reflection. We can get the same two motifs, this right hand on top and the left hand that is below, by simply reflecting across this plane of symmetry, the mirror plane. So a bar 2 is the same as M. If you have an M, you can call it a bar 2. If you have a bar 2, you can call it an M. Either set of instructions will give you the same relationship between these two motifs, whether it's a hand or an atom or a collection of atoms.